A vector field assigns one vector to every point in space. For example, it might represent wind speed or the strength and direction of a force at that point. Let's work through a worked example. We are given a formula for a vector field called f. In words, at the point with coordinates x and y, the vector has first component negative y and second component x. In symbols, f of x, y equals the vector, open bracket, negative y, comma, x, close bracket. First, let's evaluate this vector field at the point 1, 0. Here, x equals 1 and y equals 0. So the vector is, open bracket, negative 0, comma, 1, close bracket. This simplifies to, open bracket, 0, comma, 1, close bracket. Next, let's evaluate at the point 0, 1. Here, x equals 0 and y equals 1. So the vector is, open bracket, negative 1, comma, 0, close bracket. Now let's evaluate at the point negative 1, 0. Here, x equals negative 1 and y equals 0. So the vector is, open bracket, negative 0, comma, negative 1, close bracket. This simplifies to, open bracket, 0, comma, negative 1, close bracket. Now let's evaluate at the point 0, negative 1. Here, x equals 0 and y equals negative 1. So the vector is, open bracket, 1, comma, 0, close bracket. Let's also evaluate at the point 1, 1, which is further from the origin. Here, x equals 1 and y equals 1. So the vector is, open bracket, negative 1, comma, 1, close bracket. Notice this vector is longer than the ones we found at distance 1 from the origin. Now let's draw all of these vectors in a two-dimensional view. At each point we draw an arrow starting at that point, pointing in the direction of the vector we calculated. You can see the arrows curving around the origin, forming a swirling pattern. Let's also look at this same pattern in a three-dimensional view. Here, we raise each arrow's height according to its magnitude, that is, how long the vector is. Watch as the flat two-dimensional picture lifts up into this three-dimensional surface, taller where the vectors are longer and closer to the ground near the origin. Now for the check step, we confirm the pattern of arrows matches the formula. Near the origin the vectors are short since the distance from the origin is small. Further from the origin, at the point 1, 1, the vector is longer since the distance is larger. The arrows also rotate counterclockwise, matching the negative y, x formula, so the picture matches the algebra and the vector field is confirmed.